Welcome to aminacademy.com in advanced calculus regarding real number system. Let us do some solving problem. Prove that the square of any odd integer is odd. Here, any odd integer is in the form 2m plus 1. Now, squaring both sides, square of any odd integer, square is 4m squared plus 4m plus 1, which is splitted like 4. Suppose I take 2 out. 2 means 2m square plus 2 plus 1. Here 2m square plus 2 is always is even. Multiply with 2 is also it is even. Adding 1 equal odd. Therefore, square of any odd integer is always even. Next question. Prove that between any two rational numbers there is another rational number. Here, a set of rational number is closed under operation of addition and division, non-zero denominator. Therefore, look at here. Now let A and B are any two rational numbers. Now, division, that is A plus B by 2 is also rational. Since rational is closer to, since rational number there is operation of addition and division possible. Only the denominator should not be equal to 0. Now, assume A is lesser than B, then we can say 2 A is lesser than B, A is lesser than B, therefore you can say A is lesser than A plus B by 2 also, and A plus B is lesser than 2B. Therefore we can say A plus B by 2 is lesser than B, which says there is a rational number between there is a rational number between two rational numbers. Means we let a and b is a rational number. Then we proved in between, that is which is greater than a and lesser than b, is a plus b by 2 is lesser than b. So we proved there is a rational number between given two rational numbers. Next question. For what values of x 10 minus 2x is greater than x square minus 3x minus 2? Look at here, we rewrite this: x square minus 3x minus 2 is lesser than 10 minus 2x. Collecting one side, x square minus 3x minus 2 minus 10 plus 2x is lesser than 0. So x square minus x minus 12 equal to 12 is lesser than 0. Then factorizing, it gives x minus 4, x plus 3 is greater than 0. Then you can say x minus 4 is lesser than 0 and x plus 3 is lesser than 0. So x is lesser than 4, then x is lesser than 4. This last inequality holds only in the following cases: x minus 4 is greater than 0, it holds case 1, x minus 4 is greater than 0 and x plus 3 is lesser than 0. Therefore, you can say x is greater than 4 and x is lesser than minus 3. This is impossible since x cannot be both greater than 4 and less than minus 3. Here, x is greater than 4 and x is greater than 4 and x is lesser than minus 3. It is impossible. It is because x is at same time cannot be greater than 4 and lesser than minus 3 together. Therefore, case 2 is x minus 4 lesser than 0 and x plus 3 greater than 0, which means so x is greater than 4 and x is greater than minus 3. So the general solution you can write x is greater than minus 3 and lesser than 4. That means this case 2 is possible here. That means x is greater than minus 3 and less than 4 is the solution of this expression. Now next question, prove that 1 by 2 plus 1 by 4 plus 1 by 8 plus dot 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 plus is equal to 1 over 2 power n minus 1 is lesser than 1 for all positive integers, n is greater than 1. Here let Sn sum of that series equal 1 by 2 plus 1 by 4 plus 1 by 8. I wrote the given things as it is, plus 1 over 2n minus 1. Now half of Sn divided by 2, that Sn gives 1 by 4 plus 1 by 8, 1 by 16, then 1 over 2 power n minus 1 into 2 is 1 by 2 power n. Now subtracting both expression, Sn minus half Sn is another half Sn. Here is, look at here, this 1 by 4, 1 by 4 cut, 1 by 8, 1 by 8 cut, this all cut, only the remaining things is half minus 1 over 2 by n. Therefore, from this, Sn equal to multiply by 2 is 1 minus 2 to 4n, which is equal 1 minus 1 over 2 power n minus 1. That is Sn. We proved for this lesser 1 for all n. So far we discussed about some solving problem regarding advanced calculus basics. We have done. Please subscribe our YouTube channel.